Good morning, freshmen. Mr. Martineau here again. Joanne Mandarelli. Oops, sorry, Miss Mandarelli on the computer.
I have a first name.
I know, but
It's okay.
June 4th, Thursday, June 4th. We're almost there. So when last we met, we did activity 1, and this is where we were a moment ago. We were looking at the law of reflection. Now we're going to move on to activity 2, and we're going to do refraction with a prism. So, number 12. We are now on step 12 in the document. At the bottom of the sim, click on prisms. So where is that? Right there.
Yep, at the bottom.
It was at the bottom. Click and drag the triangular prism in front of the laser. So there's a triangle.
Yep.
Boom. On the right side of the screen, choose the laser that is in the dark, middle row, far right.
So the one way over here.
Way over there.
Boom.
Okay, the screen should become black. And yes, it does. Turn the laser on. Okay.
And actually, I'm going to move the laser up.
Okay.
And I'm going to move the prism over a little bit, just so this way, whoops, it doesn't interfere with the table.
Okay, so this is basically what you're looking for. We want to make sure that we can see what happens before and what happens after. Great. So that was step 15. Hold on a second, guys. Can you give me...
Yep. My map. There you go.
Thank you. All right. Here we go. Step 16. Here's some questions. What color of light is coming from the laser? So that's from the laser.
Here's the laser. This is coming from the laser.
Describe the angle of light as it leaves the prism.
This is the light that is leaving the prism.
Right. What is this? Is it the same angle as when it enters the prism? Be specific.
Enters, leaves.
Describe the step 18. Describe the light as it leaves the prism. How has it changed? So you should see a notable difference from the light before and the light after. Is the laser's light being refracted as it passes through the prism? Explain how you know. And the answer to that is not because I saw it. Okay, I mean, I know you did, but we need an explanation.
We need evidence that it's refracted. What is your evidence?
Okay, step 20. Click the laser with one beam on the right-hand side of the screen. So now we're back over here, and we're clicking that one. So now we're here, okay? Your screen will become white. Boom. Step 21. Slide the slider under the color spectrum. That's right there. Slide the slider under the colored spectrum rainbow to change the wavelength of color passing through the prism. So there's you changing it.
And I'm doing it quickly. Do it slowly.
Yep. Okay, question 22. What do you see happening to the refracted ray as you change the light from red to violet? Be specific and don't say the color changes. We know that, so that's not a scientific observation. That's obvious. We need a little more than that. Step 23. Click the normal box.
So that's down here.
Yep.
And look what happens.
The normals come up.
Yep. This is normal to this side. This is normal to that side. That's why there's two of them.
Click normal in the box at the bottom of the sim. Remember that the normal line is a line that's perpendicular to the surface. Step 24. You can change the medium of the material that the light passes through by sliding the slider in the objects box. See, it says objects.
Down at the bottom.
By doing this, you are changing the material in the prism and the index of refraction. Air is the least dense and glass is the most dense. Question 25. Slide the object slider slowly from air to glass and observe. Okay. As the index of refraction increases, because the material gets denser, what happens to the path of the refracted light ray? Be specific, don't say it changes, we know that. 26, what material makes the refracted light ray almost go backwards? So as you do it, you'll notice it goes and then, okay, it's not gonna go straight back, but which one does that happen with? Okay, so that's the end of that part of the lab, but we add in an extra credit. Because if we did this live and we had a computer lab, while students were waiting around, they typically end up kind of playing around with the sim just to make goofy things happen. So I said, well, let's take advantage of that curiosity. So, extra credit challenge, 5 points. Using no more than 8 prisms of your choice, arrange them so that the refracted ray bends back and strikes the laser itself. So what we want to do is the laser beam coming out of the laser, we want it to enter a prism, get bent, and then we want it to bend several times until it goes and strikes the prism. So we're going to do that right now. Now here's the deal with this. Now you can fool around with that, but don't give them the answer.
Oh, I know.
I know. You must attach a screenshot to this document for credit. So that's an example. So if you can see, if we keep adding prisms, we can make that light beam bend further and further back. But you got to play around with it a little bit. See? Okay. So eventually, what we want to do is we want to get this beam to come back and hit the laser. So it's kind of like shooting itself, as it were, which is kind of fun for lasers. So again, you must attach a screenshot to this document for credit. Do not submit a picture of your screen using your phone, which is exactly what I'm doing, but it's different. You must figure out how to do a screenshot. So once again, you're going to figure out how to do a screenshot and then put it right into your document. If you don't want to do it, that's fine. If you copy anybody else's, it says it right there. Again, be warned, duplicate answers among students will not be accepted. Do not share your work. You will receive no points if you do. You're not going to get a penalty, but you won't get any points. And chances are there's about 100,000 configurations that you could use to get the laser to bend all the way back to the laser beam to go all the way back to the laser. So we'll be able to tell.
Something else too, can you get closer?
Yep.
You can rotate the prisms. If you click on that little knob here, so rotate them.
Yep.
Also, you don't have to just put them like that. Like I can rotate them any direction. How cool is that?
That's
any
pretty
direction I want.
Cool. All right, so that is the instructions for your last phet lab. All right, this is Mr. Martineau here.
Oh, show them my cool shirt.
Okay, this is Mr. Martineau here, and it's her New York Yankees shirt there.
Woo!
And
most winningest team in baseball.
yeah. And I'm not a Dodgers fan, but anyways, am I on the screen? Probably not.
Yeah.
Okay, good. Anyway, that's us. So hopefully that's. I think it's a cool lab. I like.
Yeah,
to learn
it's fun
about
to play
light.
around with.
It's unfortunate that's a sim, but I've been in optics labs, and that's how the light behaves. I mean, the fact that you're not seeing it for realsies doesn't mean it doesn't happen that way. I've seen it work exactly that way in laser labs that I've been in. So that's the deal. So good luck with it. Follow the directions. Follow the video. I'm Mr. Martineau. That's Miss Mangiarelli from the House of M signing off. Thanks, guys, and good luck.
Woo!